Do you know when you think about the most famous diamonds in history, the ones that have defined royalty and just completely captured our imaginations, have you ever wondered what they all have in common? Well, it's not just that they're big and sparkly. Turns out, there's a shared scientific secret, a wild story that starts hundreds and hundreds of kilometers right below our feet. And today, we're going to uncover that secret.
From the crown jewels in England to museums all over the globe, there's this tiny handful of gems that are just different. They're legends. But for centuries, what actually connected them was a total mystery, a puzzle locked deep inside the earth. So let's start with maybe the most famous one of all.
Okay, let's talk about the king, the Cullinan. When this thing was found back in 1905, it was an unbelievable 3,106 carats. I mean, that's about 1.5 pounds. It was so huge and so pure that it ended up being cut into 9 massive stones that are now part of the British crown jewels. But here's the thing. For all its glory, the Cullinan shares a hidden secret with all the other giants of the diamond world.
And that gets us to the big question, right? What is the common thread that links the Cullinan to other huge diamonds like the Koh-i-Noor or the Lasidi-Larana? Well, the answer isn't some old myth or legend. It's actually a scientific classification that has totally changed how we understand these incredible stones.
The key to solving this whole mystery, it all comes down to a single, really powerful acronym that describes this very, very exclusive club of diamonds.
And that answer is CLIPPIR. Now, I know it sounds kind of like a code name from a spy movie, and in a way it is. It's the geological name for the absolute most exceptional diamonds in the world, and it tells us pretty much everything about what they are and exactly where they come from.
So what is a CLIPPIR diamond? Well, to put it simply, it's part of this super rare class of diamonds. They're defined by being huge, incredibly pure, having a weird shape, and, this is the most important part, a formation story that is unlike almost any other gem on the planet. To really get what makes these gems so special, we've got to crack this code, right? We're going to go letter by letter, and each one reveals another piece of the puzzle about these amazing natural wonders.
All right, so here's the blueprint. C stands for Cullinan-like. They're the gold standard. L is for large, and I mean really large. We're talking often over 100 carats. The first I is for inclusion poor, meaning they are just fantastically clean. P is for pure. These are type 2A diamonds, a chemically pure category with almost zero nitrogen, which is what gives them that perfect icy D color. And the last 2 letters, well, they describe their kind of strange appearance. I for irregular. They look more like lumpy pebbles than those sharp crystals you picture. And R for resorbed, because their edges were literally dissolved by magma during their violent trip up to the surface.
Okay, so we know what they are now. They're massive, they're flawless, and they're kind of lumpy. But that just brings up an even bigger, more fascinating question. What on Earth, or I guess in Earth, could possibly create something like this?
The answer, well, it takes us on an absolutely unbelievable journey. We're not just going deep into the earth. We're going to a part of the mantle that is so extreme, it just completely rewrites the rulebook for how diamonds are even made.
I mean, just look at the difference here. About 99% of all diamonds form somewhere around 150 to 200 kilometers down. But CLIPPIR diamonds? Nope. They come from a staggering 360 to 750 kilometers deep. That's not just a little deeper, that's a completely different world.
Geologists actually have a name for this, a super deep origin. These diamonds are born way down in the Earth's transition zone. It's a place with unimaginable pressure and totally different chemistry than where normal diamonds are born. In this extreme birthplace, it's the fundamental reason for all of their unique qualities.
See, CLIPPIR diamonds don't form in normal rock. They crystallize inside these pockets of liquid metal, a molten soup of iron, nickel, and carbon in an environment with practically zero oxygen. And how on earth do we know that? Well, scientists have found tiny little specks of this metallic liquid trapped inside the diamonds themselves. They're like these microscopic time capsules from the deep mantle.
This was a massive breakthrough, published by Dr. Evan Smith in the journal Science. His research gave us the first real, concrete evidence connecting these super deep diamonds to this bizarre metallic birthplace. It was the smoking gun that finally solved the mystery. So, now, let's bring all this incredible science back up to the surface and connect it to those legendary gems we started with. It's time to see who's actually in the CLIPPIR Club.
And this list, it reads like a who's who of diamond history. The Cullinan, of course, the legendary Koh-i-Noor, modern giants like the 1109-carat Lasidi-Larana, Every single one of these famous stones is a CLIPPIR diamond. Their legendary status, it's not some accident, it's a direct result of their super deep origin story.
And that's really the bottom line. That incredible, violent journey from a metallic pocket 700 kilometers down is exactly what makes these gems so extraordinarily large and so flawlessly pure. Their entire identity, everything that makes them the greatest diamonds in the world, is written in their geology.
Discovering the origin of CLIPPIR diamonds really makes you wonder, doesn't it? I mean, if the Earth's deep mantle can create treasures like these, what other incredible secrets are still waiting for us, locked away in the deepest parts of our own planet?